This meeting is being recorded.
Excellent. Well, welcome you all to the December 2023 Jupyter Community Call. It is the first and last one of this year, but it's really great that we'll have at least one day to see a bunch of the great work that folks are doing with Jupyter these days. So before we get going, who's excited to see some demos? We want to make sure that the Zoom is staying active. So let's use the emojis and the chat, and let us know how excited you are, because I certainly am. The first part of this event typically begins with thank yous. So I want to start out there, and Anna's going to help me in thanking folks. So Anna, please introduce yourself.
Yes. Hi, everyone. My name is Anna Rubalcaba. I'm a member of the Jupyter Executive Council and a few of our community committees and working groups. So it's great to be here. Thank you, Tony, for hosting the call, for being our fearless leader, and to everyone who participated in the collaboration that happened to make this call happen. There's a link there to the issue where we kind of talked through all of the different aspects of getting this meeting together. So thank you to everyone for being here. Thank you to Tony. Thank you for all the group of people who participated in making this happen. Tony, I think you were going to take that last item there.
I don't think we can hear you. I think your audio is out, Tony.
Have we lost Tony's audio? You can see Tony's mouse cursor.
All right. Is that? Yeah.
We can hear you.
Okay, great. Yeah. Sorry, y'all. Okay. We're back. Whoopsie. Yeah, so we have to thank all the committees that helped us bring this event together. Let's keep on cruising along here. Let's hear some updates from the Executive Council.
Yes, so I have a couple of links that I have shared here. One of them is an update that the Executive Council did at JupyterCon in May of this year. At this point, there are some minor changes that have been made to our governance, including one of the sub-projects that merged, and maybe some different, a few minor things have changed, but that presentation gives a really solid overview of how Project Jupyter is governed. So if that's a topic that you're interested in, that link will be included there. I also have a update that I just put together this week that has links for how to get in touch with all of the different working groups and standing committees. So I think some of those connection points in general are a little opaque unless you're a part of some of the core developer groups or some of the leadership groups. And so I wanted to share that out with everyone in one single document. So feel free to, I know for some people this topic is interesting, and it's usually because you want to connect with somebody that is in those groups, but for everyone else it's not. So I won't spend a ton of time going over it, just provide links to places that you can learn more.
That was great. Thank you so much for the update, and hopefully if we continue these events, we can keep staying in touch. Before we get into the demos, I want to make sure that we properly acknowledge the people who came here before us and made sure that this was a success. One person we really need to acknowledge is Isabella Presetto Floyd. She ran this event for 2 years straight. There's a playlist on YouTube where you can capture all of this. I don't think folks understand how difficult this event is, especially to keep it up for 2 years alone. And with that, she left me tons of resources to copy and paste to run this event. So y'all can be empowered to run events like this yourself. And I also want to acknowledge Zach Saylor for recognizing how important this event is for bringing sub-projects and sub-organizations together, and also has like kindness and thoughtfulness in reviving the community call, which is such a difficult topic. So it's important to recognize all the folks who've made sure that we can be here today to do this. Now we're going to get into today's event. I want to remind everybody, all the calls and chats are recorded. That is a Zoom thing. This is a Jupyter event, so we're held to the Jupyter Code of Conduct, which you can find at jupyter.org/conduct. We have a dense schedule today, so I'm going to try to keep folks to 5 to 7 minutes. And while the event is going on, if you aren't demoing, there's tons of ways to participate. Keep the Zoom chat active. Take some notes in the collaborative HackMD. I've left some space for notes at the end there. And react with emojis and let us know how the event is going. So with that, it's demo time. Is it going to be a demonstration or a demolition? Let's find out. I think up first today, we have Michael Gores. Michael, are you with us?
Yeah, I'm right here.
Awesome. Well, you've got the floor for the next 5 to 7 minutes. So let it rip. Well, actually, let's get your screen shared, and
Right.
then we'll start the timer. Nice. I'm seeing a terminal there.
Yeah, well, I'm just gonna sort of, go through things, demoing. My name is Michael Gertz. I work at the Army Research Lab, and my background is kind of in doing numerical quantum control. So I typically have some kind of project where I do some kind of modeling, or I run numerical simulations, and it's typically a mix of Julia and Python notebooks. So I usually have a project folder like this one, and I'll have a make file, and that just sets up the Julia as well as the Python sort of .env folder. So I'll just have something that's set up based on a requirements.txt file or something like that. And very specifically, I kind of want to separate the project environment from the Jupyter front end. So the Jupyter, like the whole Jupyter app, that's just something that I have like in a separate content environment. So the .env folder for this project, that's going to include the IPython kernel, but it's not going to include the entire Jupyter Lab installation. So note that when I have in my make file, I'll have somewhere here I can do make Jupyter notebook, and it's going to run the Jupyter from my main installation, not from the project.
And run this is a system of many users.
So then for the notebooks that I have in Julia, it actually works really nicely, because in Julia there's just the single iJulia kernel, and you install that into your main global Julia environment, and that automatically picks up the project folder that the notebook is in, and just use that local environment. So that's really nice. But for Python notebooks, it doesn't happen the same way, right? So there, the default kernel is basically tied to the global environment that you have Jupyter installed in. So what I would used to do in these make files, so this is an older make file from an older project, I would have this make install that gets called sort of at some point, and it's going to install my project kernel into my global environment with a name, and that works. And I have to keep track of that, and that works fine. But you have to choose the name, and then you have to manage it. And if you have a dozen projects, you're going to have a dozen kernels show up in the Jupyter Lab. So I basically wanted to have the same behavior in Python that I have in Julia, where there's just one kernel, and that picks up automatically the local environment in the local.env folder. And there was something like that called a poetry kernel. That works if your project environment is managed with poetry, but I'm not really a poetry user. So I'm kind of sort of agnostic about that, or generally just use pip. So I basically just tweaked that kernel a little bit, and that is so I just basically forked it and modified it, and this is here on GitHub. So it's just called Python local env kernel, and you can install it either via pip, or basically I just install it into the global environment that I have my Jupyter Lab installed in. So I just do that once, and that kernel basically just looks for a .env folder in my current project, and then it's going to delegate to that. So like in my sort of newer projects, so I still have in the make file I set up the local the venv, but then I don't have this install or uninstall or anything like that. So I just directly call Jupyter Lab. So I might just do make Jupyter Lab, and that now the environment is already set up. But if it wasn't, I could install the environment, and then I can open that. And now here I have my notebooks. So I might have a Julia notebook here. So this is, this sort of works by default. So that picks up whatever's in that local folder. But then here for a Python notebook, if I run that, I can sort of verify. So here I'm just using SymPy, and if I check like what SymPy it's using, so it's using the SymPy from that local project folder, and that's you can also see here. So there's the kernel that sort of is set up for that, and if I open a new notebook, it's there's the kernel here, and that just always delegates to whatever the .ven folder is, and that's pretty much it. I mean, there's some other things you can do. There's a README here and some FAQ. So you can actually change if you don't want to use a .ven folder. You can use an environment variable to point that to something else, and that actually makes it quite flexible. So you can even point it to like an absolute path if you wanted to. But that's basically it. And it's I don't know. It seems kind of like something that almost should be built into Jupyter as sort of a behavior that it sort of managed that you just install one kernel, but it manages to pick up on sort of local environments depending on some other settings. That's pretty much it.
That was excellent, Michael. Thank you so much for that share. If folks have any questions, let's try and handle them in the chat so we can cram as many demos in as possible. And Michael, it looks like you've got some cool notebooks too. If you've got any with some like cool equations and diagrams, I'm sure folks would love to see that also.
They're on my GitHub pages, usually at some level. I mean, some of them are kind of internal and private or not published yet, but anything eventually makes it onto GitHub. So
super cool.
Stalk me on GitHub, and
we have the HackMD, and there's a notes section at the end. So I'd really appreciate it if you and any of the other presenters can go along and add as many links as you can to your specific topic. This way, when we publish it, folks will be able to find where all the good stuff is. Thank you, Michael. Great first talk. Well, let's keep it moving. The next person I have on the agenda item is Shravan Achar.
Tony, can I help with timekeeping?
I think I'm good during this part. Thank you, though. Just that last, we need to be done by like 9:53, 9:54. That's the one that I'm gonna forget about.
Okay.
Thank you.
Good.
All right, is Shravan here?
Yes, I'm here. I hope you all can hear me okay.
We can indeed. Yeah, we'll get going once your screen is visible. Thank you for being here to share.
Sure. Thank you for having me. So this is, let me share my screen real quick. So give me just a second.
Take your time.
First time using Zoom. Should have done that before.
If you,
I think we lost him.
did we lose him?
Yeah.
That's all right. All right. So if folks run into any technical issues, we have a full agenda so we can move people around, but we will get to you. So if Shravan shows up, can somebody please message him and let him to know, calm down, take his time, and we'll make sure that he's on the agenda. Thank you. So to continue things along, our next talk is going to be from Eric Gentry.
Oh.
Hey, all right, so I'm going to talk about my in-progress hex editor for Jupyter Lab. I'm just calling it Hex Lab for now. So there's links in the HackMD notes if you want to take a look at the repository. But I'm going to go ahead and launch. I'll launch Jupyter Lab. I'll share my screen, which should help. All right, can you see Jupyter?
Yep.
Cool. All right, so right now you open it by using the command palette. So I'm going to open the command palette and type hex editor. So that's going to open a hex editor panel here for you in Jupyter Lab. And I'm going to go ahead and load file, and you can just pick any file on your computer. So I'm going to pick this image file. So this is a PNG, and if people are familiar with the binary format, you can see the header over here. But this works kind of as you would expect. You can click around on the left side, you can click around on the right side, they stay synced. you can scroll around kind of as normal, and there's a page up and page down feature as well. And then kind of last, you can resize by like dragging this middle control here, or you can use the arrows. So if you want to change the width, there's easy controls for that. And that's all I have right now. I'll pull up where's the repository? Where did I put that? Here it is. So here's the repository for this. I think a lot of the difficult UI stuff has been finished, so I'm going to be rapidly adding things to this, but that's the state I'm in right now. So the plan eventually is to be able to view files that are larger than system memory, and to view files remotely over the network, and to view large files over the network very efficiently. So that's all I got for now.
Wow, that was great, Eric.
Thank you.
So was this part, were you motivated to, was this motivated by learning how to use extensions and understand the ecosystem a little bit better?
Yeah, for sure. So this has all been good research for me, and sharpening up. I think there's it's always kind of a long walk, I think, to spin up on all of the extension development and all of the related packages and tools and ecosystem stuff. So this has definitely been really valuable for me to sharpen up on the Jupyter stack in particular.
Well, that's awesome. Thank you so much. Do we have time for one question for Eric? Does anybody have one? Jason Grout says, awesome. Just curious, can you open a file in the editor from the file browser on the left?
I was screwing around with that earlier today. I tried to hook into the MIME render extension API, but I haven't done that yet. I don't think it should be very hard to, but that's on my to-do list for sure.
Well, I'm excited for you to learn these things, especially knowing that you're leading this documentation effort in Jupyter, because I feel like you're going to take a lot of this knowledge that you gain and give it back to the community. So thank you for sharing with us, Eric.
Thanks.
All right. Very, very cool. So we're going to try and get back to Shravan. Let's see if we can get your screen this time. Yeah.
Thank you. Thanks again. Let me try if this works. Okay. I think it's working.
Great. You're good.
All right.
So take a breath.
Thanks.
Take your time, and you got 5 to 7 minutes.
Awesome. All right. Okay. So I want to talk about a share button that we introduced to our hosted Jupyter Lab service. So just a brief background before that. So far, before that, let me say I work for Apple, and we have a pretty large hosted Jupyter service, and this is my instance. And our users often have to share notebooks with each other, and they, as with everyone else outside in the community, they use GitHub. They essentially publish the notebook to GitHub and use GitHub permissions to share with other users. And we have found this to be limiting. It's essentially, we're limited by the permissions that GitHub provides. And it's not very well suited for all the cases. So we want to do something better. So here we have a simple share button on the server UI, the front end. And essentially what that does is you have, let's say I have a notebook file here. A bunch of tabs open, and each tab has a share button visible. And let's say I work on my notebook and done with it, and then I decide to share it with some other user. So first is I just go and just press this button, and it gets published to this external service that we've written. And once that's published, you can use the permission model that we've defined and share it with other users. So essentially, once I press the share button, it presented me with this modal, which you can put in usernames, and we have group names as well. which is pluggable with any group service. So essentially, let's say if I choose Zach's name here, who's my colleague, and he let's say I share with him, and done. That's it. It gets sent to him, or this notebook is available to him immediately. Just to see how it looks like. I can also copy this link here, and go to this tab. I mean, let's say I'm Zach, and then I'm just putting this link on any browser window, and then it should take me to this page with the output and everything. So it's taking a while, I suppose, for some reason. Let me see if I refresh it again. And yep, here it is. So it's a static HTML version of the shared file that everyone I share it with is able to see it and consume it however they wish to. There's also a way to copy this link without stripping all the code. It's simple enough to do, which is just remove all the code and only have the output. That's possible. So yeah, a lot of architecture behind this single button. You see here just output. So, and interesting part is it's just not something we see on any browser. It's available immediately within a Jupyter Lab instance. That is, if you see, I have this left tab panel here where I have a bunch of files shared with me, and then I have I just shared this NumPy sample file 2 minutes ago, and it's been visible here. And if I was the receiver, then it would be visible in my shared with me. So yeah, I think it's a simple way. Let's assume that I wanted to preview some file that was shared with me. Let's say it's something like this file, right? So I can preview it, preview the file, and then download a copy of it to my workspace and then work on it, and then it will appear here. So that's what we have, and I think one of the things that I want to mention here specifically, it's this service that I've written is backend agnostic, built with fast API, and following the Jupyter model, where each component is pluggable, we have extended the Content Manager API and implemented a file service on top of that. So essentially, you could take that, you could take this service and plug in your own file service by implementing the Content Manager API again, and then that's it. Then that becomes your storage for these files, and we're trying to define the interfaces required for other things that work with this. So essentially, it's pluggable, so you can swap few things out and put things in as you need it. And I think that's our goal. So far, it's not.
Yeah, this is a really awesome feature. It's looks super familiar to collaborative Google Docs, and these notebooks that we write, they mean more when many folks are participating. Thank you so much for that share, Shravan. Really appreciate it. Again, add some links to the HackMD and in the chat so that folks can find this and that we can share our notebooks with each other. Thank you so much. That was awesome. Cool, great stuff. All right, now's time to see if heads will roll. We got Nick Bolweg demoing JupyYak. So I feel like you're going to need the full 7. And if we don't, people will have time to get their balance afterwards. So
yeah, it's cool. I'm starting it for 6 right now, so we'll rock and roll. All right, because I don't trust you. All right, this is Jupyter. Jupyter is a thing that lives on the internet. Please don't try and run it locally. That builds previews of lots of different PRs across lots of different repos in Jupyter on both the Python and the JavaScript side. And it gives you a page where you can actually use them as a human. It's a common trend or a common theme in a lot of the problems that we have with things like accessibility testing. I want to evaluate the accessibility of, say, iPyWidgets, but I need a change down in Lumino in order to make that actually work. But then I have to actually run it in some place that has the corresponding iPyWidgets, the right IPython, all those things. So this extends off some work, again, from the accessibility piece that we had done previously. And it was more focused on Binder, but Binder doesn't work anymore much. Sorry. And so we needed something that was lighter weight. So let's look at an example real quick. This is a PR that I created, and I wrote it by hand. I used a file editor for it. And this is what a Jupyter configuration looks like. I'm eventually going to pull a gist. That's going to be the stuff that we're going to look at. In order to do this, I need a specific PR to iPyWidgets. If it's not on GitHub, I don't care. I'm not going to build it for you. I'm sorry. I also need some stuff from Jupyter Lite because I wanted to see how this all works against the Jupyter Lab 4.1.0.alpha 4 as of this morning. Maybe it's already beta. I don't know. Jupyter Lite got a little bit out of sync from the upstream notebook and Jupyter Lab application. So I had to monkey with a few things down in there for making them all linked together with Yarn. And then it also needed a new dependency. So I had to add a couple hacks here. Let's go look at what that looks like. But you got to go to the right place. You got to go there. 3 minutes. I burned half my time. That's lame. So what you get when you get there is something that looks like this. With nothing at all. Hey, there we go. Look at that. So then you crank that up. You now want a nice big one. So what we're looking at here is the absolute latest Jupyter Lab, the absolute latest Jupyter Lite, the absolute latest notebook, the absolute latest iPyWidgets as of this morning. Yeah, so I was going to lead with this, but I felt like a little bit more familiarity. So one of the marquee features that I wanted to see, because I wrote it, is Mermaid. So this is a Mermaid file that exists inside of my Markdown. It's getting rendered. Looks like there's some font screwage. So that's just is what it is. So this is Jupyter Lab Deck, which is an extension that I built, and it's using Jupyter Lab fonts. That's why you're seeing Atkinson Hyperlegible instead of whatever a Linux box has. But this is a full Jupyter Lab site. We can pop into here, check my versions. Let's go.
And this is running on Read the Docs, right? No server.
That's correct. There's no server. Yeah, 1 million people could come look at this right now. Hell, I'll give you that PR. Go have fun. Let's just drop it in there. It's not going to fall over. Path equals readme.md. All right. Should have preloaded that. All right. So yeah. So if we want to look at some proof, I go all the way down here and I look for some Jupyter junk. Get out of my way. Yeah, there we go. 4.1.0 alpha, and I could probably find Jupyter Lite in here somewhere too. 0.2.1, we post bump the version, so whatever, but trust me, it's all in there. Yeah, so that's the big deal here. Let's look at a better example that's not just frivolous demo junk. This is one that Tony and I have been punching on for a long time. So this is based on an upstream collection where some contributors have their own PR system where they're evaluating stuff, but it was hard to do this in the open. So we're bringing in, quote unquote, all of these PRs in order to get an accessible site. Let's take a quick look at that. This one's a lot simpler. It's just one Lumino PR and then a whole bunch of Jupyter Lab PRs. And from that, we get some new features. Pop into here. So the big marquee thing here was some handling of the keyboard. So as you can see, I'm not moving my mouse. I'm using my keyboard. That already worked. What didn't work before was I open one of these and I go back. Now you can independently interact with that. I press delete. It's gone. And there we go. So we were just able to do something that took a lot of time otherwise. This thing does a lot of freaky stuff on read the docs. We can go pop into it. We got 24 seconds. So this is everything that it has to do in order to build that. This is what you built. Look at it. Gaze upon its glory. Bottom of the stack is traitlets. That's not even big enough. Bottom of the stack is traitlets over here. And all the way at the other end, we get a Jupyter Lab build over here. And you can see all the complex stuff along the way. And I'm out of time. Questions? You also
Killer.
logs.
One
Lots of logs.
question.
There's also
Anyone?
a big old form. Let's build a 21. Oh.
Yeah, we'll be
Right.
seeing more of this. We've actually been able to test things that we wouldn't have been able to test otherwise on this. So it's been great progress, and we've been able to iterate on it. So thank you for all this effort, Nick, and thank you to like everybody in the community that's talked through this problem and their needs over the years. Like this has been like 3 or 4 years long looking for this solution. So thank you so much, man. And if there's any questions for Nick, throw them in the chat and share any relevant links. Thanks, y'all.
Very, very impressive.
Thanks, y'all.
Well, I am very excited. I have not seen this gentleman in quite a long time, but we have Kyle Ray Kelly presenting next. Are you here, bud?
On mute. Totally here. Good to be here.
Excellent. Oh, it's so exciting. So exciting.
Okay. Hey everybody. Yeah, I'm Kyle. And I've been working a little bit on the Deno kernel to work on having TypeScript inside the notebooks. I haven't always been pleased with what was available for Node in the notebook, mostly because you need to have relative Node modules. So when I saw that Deno had ESM top level async await, I was like, oh, I want to see if we can make that a kernel. And they had like an old issue saying, hey, we'd like to do this at some point. And I was like, oh, they're game on. So walk them through how to fix certain things, help them get a display API, and then it's just kind of building steam from there. So I'll give at least a little bit of a demo of it. Everybody knows JavaScript, or so I assume everyone is forced to as a programmer. So this is just classic console.log. Because this is V8 based, you can actually do console.table. It's part of the Chrome Dev Tools. And then, of course, you can import relative files, like if you had something locally to work with. And then you can also load from HTTPS URLs. So if you haven't seen Deno before, you can load literally from an HTTP endpoint. You can load TypeScript directly as ESM, and it'll transpile it on the fly. And then you can import node modules, work with those directly, and import modules from npm. So standard stuff, but you get kind of all the joy and the pains of JavaScript all in one. And then, yeah, so built-in TypeScript support. I'm going to skim down here and then get to some other exciting stuff. And I think the big thing that I really love out of this and working with Deno as the runtime is that it tries to be standards like web compliant as much as possible. And you could even see like Deno started appearing on the MDN pages to show their support for fetch or URL or various APIs, kind of all the JavaScript. And Node is starting to appear in some of those too. So it's like, where is this supported? You can find out, does this work in the browser? Does this work in Deno? Does this work in Node? So that's URL. But let's get into why we do this stuff in the notebook. So Deno has a display API just like IPython does display. So here I'm going to show it with raw true, so I can just do like the raw payload of that media bundle, that MIME type bundle. So you can do that with JSON, plain, all that kind of stuff. Most importantly, though, you can get access to a canvas. So if people have worked in the front end, you get access to a canvas. You can draw on that canvas. In this case, I'm going to draw like just a red square and then display it. And actually, we can make this one a little bit easier. So this one's using display directly, but Deno also recognizes if you just display the canvas, it knows what the type of that object is, and we'll just go ahead and display it. So you can basically plot inline using utilities that you've done on Canvas before. So here's another one. Here's a little smiley face. So this is using SVG. So if you can write SVG and actually no, this one, yeah, this one is. So that effectively, you can draw to arcs, which if anybody works with D3, you're used to drawing effectively arcs to do a lot of the plotting. And I'll get to that a little bit more in a sec. So just skimming through this is just more examples of plotting directly. And GeoJSON. So it's basically everything that we've already been built in Jupyter is now exposed, but for JavaScript developers or anybody that's working with that wants to share. So I don't remember what points I grabbed here in Santa Cruz, but yeah, there's some geos. So how does this work under the hood if you wanted your objects to show something? So like we did for Jupyter, we helped establish standards for people to export, text plain or HTML, using the rep for HTML and rep for syntax. So like here's an example data frame, like pretend you had an HTML in Python. So with Deno, the way you do this is you, on your class, include this special symbol that's symbol.forJupyter.display. And that just basically makes it so it's a unique symbol, but kind of across your runtime to work with. So here I'm going to create a class vector2D, and then you just define a function that will return that media bundle for you. So here I've made this little vector class, and all it's going to do is point to X and Y on a little 2D vector. And there's our vector pointing to 100, 100. Not the best implementation because I'm not dealing with axes and all that, but just to do a little bit of a demo. And just to, I don't know how I am on time. I'm kind of running right through it just to show people stuff.
Let's rip through one more notebook.
Whip through one more notebook. Cool. So this is doing React. You could do Preact or any other JSX. You can literally write JSX inside of the notebook, render it to a string using the React on server render to string, which means that you could render it directly to Jupyter. And so if I like go down here all the way to this, you could literally write out components, use components that you use today, and then render them inside the notebook to play with. And if I guess in a future week, in some far future, I will show how the widgets work with this too, because then you can have full interactives. I'm going to cheat though, and I'm going to give one other demo. This is using D3. So you could literally use D3 to draw onto that canvas because you basically can create the drawing instructions out of D3. So this is all server side. So it's doing a plot.
Yeah, this is great. This is really awesome, Kyle. Hopefully, I want to see this in Jupyter Lite sometime. But there's some questions in the chat. Maybe you can answer those and share some links with us. But thanks for sharing this, man. It looked really cool. It reminded me of Jupyter Classic. Just seeing a bunch of JavaScript intermingled with some Python. Good nostalgia there, Thank you so much. Let's motor on and let's get Mason Williams up for a talk.
Great, awesome. Thanks
Cool.
for having me.
Thanks for being here.
Should be here. Let me know if you can see my screen in a second. Oh, I might have to quit and reopen due to security preferences, of course.
Okay, no problem. So what I'm going to do is I'm going to bring Andre on, and then when you come back, you'll come after Andre. Is that
Yeah, that works.
Great, thank you. Is Andre here? Andre?
Me? Can you hear me? Oh.
No, there's a speaker. Belikovic?
It's me, yeah.
Yes. Sorry.
Okay,
Yeah, no
okay,
worries,
good,
no
because
worries.
I was a bit flabbergasted.
Do you want to give you a demo first before me? It's fine.
Oh no!
Go ahead.
Demo. Please go on.
I was pronouncing names wrong. It was my my bad accent. Yeah. Could you introduce yourself and tell me how to pronounce your name properly, please?
Yeah, absolutely. Yeah, you can you can call me Andre. I think it's okay. So hi everyone, folks. Thank you so much for inviting me. I'm actually part of the same team as Shravan and Zach from Apple, from same team as Data Platform. We're building the notebook-based solution for Data Platform. And I came from the Qflow community. So I've been in the community for the last 5.5 years. And we made a lot of really cool integration within Jupyter and Qflow and how to scale your ML experiments. And today, let me just to share a few quick demo with this. So I have just 5 minutes. So I don't have much time to tell you everything about it, but just give me a second. So, yeah, before I start, I just want to quickly say that we see Jupyter like a powerful tool to do all flavor of machine learning, like machine learning lifecycle. And we think like integration between like different, projects within Qflow and Jupyter can like provide much more power for the users. And this is like the first version of how we see how Jupyter and other ML libraries can play together. We actually showed this demo during the KubeCon on the hotspot, and the RTC was working like even better than compared to, like the hotspot bandwidth network. So this is like the first version of RTC working on the real product. And like it's the demo, as you can see here. I'm going to show you a recording because like it will be faster than showing the live. But basically, this notebook is powered by RTC, which means like we can together, me and Zach can collaborate on the same notebook and do more, a lot of more sophisticated things. So as you can see, my screen on the left side, Zach's screen on the right side. We kind of like located in different even places. So Zach is in the US, I'm in London. We can, collaborate on the same notebook, which is basically built inside the cloud. We can, like have all the computation around the graphs inside the notebook. So we can work together as two data scientists. And also like I want to share this notebook is actually powered by GPUs, which means like we can even do much more with a notebook. We can do some prompt engineering together. So in these particular examples, you can see which is generating some plot using the Plotly lab, but also we can use the Hugging Face API to test some models. So we're just taking the stable diffusion model and just try to see how this model actually can do the predictions. So on the left side, you can see I'm trying to generate some random prompt and generate some images. And these images actually show you on my side, on the left side, and also on the Zach side. So we can do prompt engineering together. We can use like a lot of like very large models with a notebook and power this notebook by multi GPUs, which gives a lot of power of how like data scientists can play with this tool. And also, like as I mentioned, we try to integrate more kind of ML story inside a notebook. And basically, we use Qflow as the underlying machinery to scale the experiments. And in this particular example, basically, I'm showing you how we can run hyperparameter tuning experiments within a Jupyter notebook. So we're creating like some sort of the Qflow kernel, which allows you to scale the ML experience from the notebook to the cloud using the multi GPUs. So here, like we try to create like familiar interfaces for data scientists to play with. So the data scientists, they know like the PyTorch, they know TensorFlow, so they can define the training code directly in the notebook. And then they can even like use this notebook to test this training code. So basically the first iteration just to test that everything is working inside the notebook. And the next step, we kind of like have integration between Qflow to scale this training code to the cloud. So Qflow has a several kind of API. I'm not going to explain everything, but basically data scientists can use the pure Python SDK to trigger the Kubernetes API and Qflow machinery to scale this hyperparameter tuning experiments directly from the notebook, which means here I just, as a data scientist, need to define my tune function and here like explain what kind of my objective here, what if my hyperparameters, I want to use like Bayesian optimization algorithm to tune my hyperparameters, and some other like information about my scale. So basically here, as you can see, I can define how many trials I want to run. So if I want to run like my experiment on like, for example, 100 GPUs, I can just modify one value and the machinery behind the scenes will scale my experiment. And also like, as I mentioned, we kind of like integrate Qflow more to the Jupyter ecosystem. So data scientists can also like have a UI on the right side from the Qflow side and a Jupyter notebook on the left side, which means when I create my experiment, it actually runs experiment on the cloud, but not inside a notebook, and allows me to analyze the data in the different places. So basically, we integrated the Qflow UI inside Jupyter Lab, because Jupyter has all like flexibility and extensibility. So here, like I can analyze my results as I start my experiment. I can go inside the specific experiment, or for example, the one I created before, and see some information about the metrics, about the high parameter visualization tools. Also, like as a data scientist, I can go inside the trials to check the logs. So yeah, if I just try to go
The users must really appreciate being able to have access to this stuff without having to go to the native dashboards.
Exactly.
I've never had that experience. So some of your users are certainly blessed to have this. Thank you so much, Andre. It was a really great presentation.
Yeah, I just like, I think then I just want to mention like a few things. I think please get in touch with us if you like if you want to be more collaborative with this, and if you want to check the full recordings, check this link. Because like we give a talk this on the KubeCon, and we have like the full explanation how this works behind the scenes. And also you want to reach out to whether all of our communities, please check these links. And we believe that we can bring Jupyter in a more cloud native environment because it gives us much more power to attract more users and provide the scientists a great tool to build their models for the whole ML lifecycle.
Yeah, that's great. Thank you. If you could do me a favor and duplicate these links over in the HackMD or somewhere Jupyter, this way we have a record of it. And thank you so much for sharing your team's work. It's really great stuff. We're going to do, just to prepare y'all, we're going to do one more talk. So let's get Mason back up. And then after Mason, Anna and I are going to do some farewell notes, and we have one more talk after that. So Mike, if you can hang around, let's do that talk after the outro. If that's okay, well, we can sort that out in the chat. But in the meantime, let's get Mason on.
Awesome. So yeah, just let me know if you can see my screen here.
We can indeed.
Awesome. Okay.
Load bean search.
Okay. Awesome. Yes. So yeah, I'm Mason Williams. I work at a startup, dev tool startup called Pieces for Developers. And essentially we are like in-house machine learning, but AI enabled developer tools all across your workflow, from the research phase to the implementation to production to maintenance, all the way through. And so I want to keep this kind of Jupyter Lab focused, but we're also in IDEs, browser extensions, essentially across your entire tool chain. But so yeah, we're going to start in Jupyter on the left side. We have a beam search notebook here, and we're just doing some research and running some models. And we actually have this really nice this extension where we can directly embed what we call our Pieces Copilot. And so, yeah, everybody has a Copilot these days. But the one thing that we kind of pride ourselves on is the fact that we can run completely air-gapped, completely offline, using local models that are downloaded on your machine. And this is all powered, you'll see up here, by Pieces OS. And so we have this kind of backend that does our data processing, and then we kind of tap into that from all of our different avenues: VS Code, JetBrains, Jupyter Lab, whatever extension that you're using. And so one quick thing that I'll just go through, since we're on a time constraint, is so we have this kind of entry, we're loading our models and getting our base path set, and we can actually ask Pieces about this current selection. So we have all of these you can save, you can even share this with other people, enrich it, but we're going to ask Pieces about it. And you can go as simple as, what does this do? And obviously you can get much more technical, but for this talk, we'll just keep it very simple. And it's going to give you a really nice answer like you would expect. But going further, so you can see we're actually using GPT 3.5 Turbo. You have the ability to lock into 16K, GPT-4, Palm 2, but also these on-device models. So you can download the GPU or CPU version of Llama 2. Simply just check, and we're using Llama 2 now. So we're actually just going to ask this pretty generic question. And of course, it's not going to work. I love live demos, but I think that's something on my end. But the point is that we are kind of very horizontal. So we're adding Mistral model, which kind of has blown machine learning out of the water lately. So that'll be available very soon. We're adding Gemini as well. But essentially allowing people to tap into their local resources. And this is really big for enterprise as well. Enterprise has a lot of compliance issues with using, cloud models. And so the ability to have essentially an on-prem, on-device model that you can use throughout your workflow is really awesome. And it kind of ties into every aspect wherever you are. And so we actually, let me restart this. I think it crashed. So we actually began as a snippet manager company. So we have the ability to save these snippets, and you can easily, look back, look through your workflow. Maybe I saved a conda activate snippet. I was working in the RStudio. And so let's say we actually want to save this snippet. So we can easily go save active cell or save selection. We'll just save active cell. And this is all using webhooks. So immediate update, no need to refresh. And you'll immediately notice that we get a really nice title snippet from exactly where this came from in our file as well. And we can actually expand this and get even more information that we're all doing on the back end. And so we get associated tags. So we get Onyx Beam, Surge frameworks, quantized model beam. We get smart description. So this code loads a beam search model from the Onyx file and sets its name to obviously blank. We don't have a name in. But also it gives you some suggested searches. So we have a desktop application, which I'll bring up, which is kind of our flagship product. And so everything links back to this desktop application. You see it just loaded in. And we see the same replicated info wherever we are. We have Chrome extension. You'll see the same thing there as well. And then we can also go to VS Code and we'll see the same thing there. But the really awesome thing is that we'll even give you related links that we find in our models. So we'll give you doc links, we'll give you package links, even sometimes blogs that are associated to it. And then going further down, related people. So let's say, I know a couple people demoed before with people working together. We can look into who has been working on this file, even down to the line, using services like Git, the line of code. And we can say, hey, one of your coworkers worked on this before. You should contact them, or you should get in connection with them to help you out with this, and things like that.
It's nice to see Copilot tool potentially connecting people and not further disconnecting us.
Absolutely.
This is a really cool interface, Mason. Thank you so much for sharing. If you have any links or videos to what your company does, or any open source tools that our community can use, please share them in the HackMD. And we really appreciate you bringing that demo to us. Thank you for fighting through the technical problems.
Absolutely. Yeah. And we have a big open source initiative that we're doing right now. And so, yeah, I'll post those links so you can get active. Absolutely. Thank you for having me.
Thank you, Mason. Really appreciate you.
I think, Mason, did you find us on Reddit?
Yes, I did. Yep.
Cool.
Just one place where Jupyter users are.
Yep.
Good advocacy work there, Eric. Great advocacy work. Thank you. Yes, we have to meet people where they are. That's the only way this works. But let's see. I think we mostly saw a bunch of demonstrations today. So I am extremely happy. Thank you all. But we're going to wrap up. If folks have to drop off, please do. Usually folks hang on the call afterwards, so feel free to stay on. But before we wrap up, Anna and I had some things that we wanted to bring to the community. So Anna, I was wondering if you might throw out this suggestion for us, please.
Yes, thanks, Tony. So today's call was possible because the Jupyter Lab team let us essentially take over their regular weekly meeting slot for community time. And this is something, hopefully, based off of today's experience, that we can replicate in other sub-projects. So what the suggestion is, or what the hope is that we'll take the work that Isabella created through her documentation of the processes to run this meeting, And then on a monthly basis, if you all want to see this call again and see this experience again, we'll replicate it by having different sub-projects essentially take over the community call for the month. So I think this could be a place to stimulate kind of cross-project communication, and essentially just establish a wider sense of community. I think Jupyter has gotten so big that there's definitely times when even among the sub-projects who are a part of Jupyter, we don't know what the other is doing. So Tony, what do you see as the next step for that? I don't think that's clearly defined in my mind. This is something that I would love to see happen. And I think it would alleviate the burden from just one single person running these meetings to having multiple volunteers and contributors. So what do you think is the next step to actually make that happen?
I think, I've been advocating for this for a while. Isabella's been advocating and Zach's been advocating. But today's the largest meeting that we've had with Jupyter all year. We've had 45, 46 people at the highest, and that's awesome, right? But what I really need from you all is I need the community advocating for these events, and also a place for this to be an officially recognized effort that is going on with Project Jupyter. So as governance is forming, I need your advocacy on Discourse and on GitHub, making sure that these community calls happen again, making sure that we find hosts, making sure that the hosts are supported. So this is a community effort. It takes community advocacy, but the way that we all came together for this event was representative of what we're able to do together. So yeah, that's my suggestion. I got to thank everybody for being here and attending. It was great.
I did want to
Anna,
give
yeah.
one last plug to the fact that Jupyter is now active on Mastodon. And so I want to put a link into the chat there. If you're not on Mastodon, encourage you to join us there. Moving forward, that will be our kind of primary channel for amplifying and boosting messages across the Jupyter community. So I really want to encourage everyone to follow us there.
That's great. And if people have any social media questions, there's a social media working group that's forming now. So that is regards blogs and social media. I don't know when this next community call is, but I really hope that you all can come together and make sure to see it happen. In the meantime, for folks new to the community, we have a documentation working group that's being formed right now. And also there's a triage event led on Tuesdays. So there's links to this content in the HackMD. Please continue joining our events. I hope you all enjoyed your time here. And if you have any comments, we have an issue on the Team Compass. Aside from that, the Jupyter Lab meeting needs help hosting. And we have community resources to help you and support you. So if anybody is looking to be a community leader, please let us know how we can help. So with that, thank you, everyone. Jason, let's kill the recording so that I can, yeah.
Thank you so much, Tony, for hosting. I'll stop the recording momentarily. Brace yourself.